Okay, for the second one, only 15 minutes first, so let's get going here. We have a Web of Books is an online business that sells books exclusively online. They operate on a 12-hour day beginning at 7 a.m. I just want to make a note here that if we're starting at 7 a.m., this T hours then would represent 8 a.m. This would be 8 a.m. This would be 10 a.m. This would be 11 a.m. and so forth, because it's hours since they've opened. The differential function P of T is used to represent the rate. So I'm just going to highlight that because that's an important word. P of T is a rate. It's not the original function. I also notice that they use the word differentiable. So that means that they could ask a question about MVT or EVT or IVT, at which online orders are processed. I'm going to highlight that phrase because that can always come up when they talk about giving units. So this is online orders are processed in hours. And then the twice differentiable function, again, S of t, so they give us two functions here that we have to work with, one in a table and one in a piecewise, is used to represent the amount of orders shipped at any time t. So again, this is shipped, so there's two verbs here. There's product coming in and product leaving, again, at the same time t, and it's also a rate. The various rates at which orders are being processed are given in the table above, along the piecewise function. Both functions are valid from 0 to 12 only. Okay, so that last part we cannot extrapolate. We have no idea what happens outside of those hours. And I believe that's everything that we can really glean from this table. So from this information. So let's go ahead and go into the problem. Is there a value of t from 3 to 8, the closed interval from 3 to 8, such that p prime of t equals 1/2? Show the work that leads to your conclusion. So let's take a look at that and see what's happening here. From 3 to 8, first of all, such that p prime of t equals to 1/2, I think two things here. I think IVT, I think MVT. If it was IVT, then what they would give me is a table of p prime and t, and there would be a value here that would be less than 1/2 and a value here that would be more than 1/2. But they don't give me that. They only give me p of t. So that means that this is not an IVT question, and if you didn't understand that, please rewatch that part to make sure you know what I'm talking about. This is going to be an MVT question, so I'm going to start off. Is there a value of t? Well, let's go and do MVT means that you're going to need the slope of the secant line on that interval to equal the slope of the tangent line. So we need the slope of the secant line between these 2 points should be equal to 1/2. So let's find out. Let's do p of 8 minus p of 3 over 8 minus 3. P of 8 is 5. P of 3 is 2.5 and over 5. We get 2.5 over 5, which is 1/2. Okay, so we do get 1/2 out. That's great. So my answer to the question is the following. There exists a time t on the closed interval 3, 8, because on 3, 8 such that there exists a time t on 3, 8 such that p prime of t equals 1/2, because p of t is differentiable, and then you would just put in this part, and p of 8 minus p of 3, p of 8 minus p of 3 over 8 minus 3 equals 1/2. And then you're done. Oh, and I'm sorry, one more thing. By the MVT. Always give credit where credit is due. If you use the theorem, always state it. Okay, and that's your answer for that one. I'm sorry that this part didn't come out as well as I would have liked to for typing, but that would be the answer. Let's go on to B. Now it says use a right Riemann sum with the 3 subintervals indicated in the table to approximate. This is supposed to be an integral here. To approximate the integral from 12 to 4 to p of t. Explain the meaning of your answer in the context of the problem. And by the way, I didn't show you. Our answer is correct if this was an MVT question. Okay, so for B, right Riemann sum with 3 subintervals from 4 to 12. So here's 4 to 12. And in my class we did, and I think in Schwartz's class, I always draw 3 lines between the 2 intervals. And I always draw to the right if I have to do a right. I would draw to the left if I had to do the left. And that's it. I do want to show midpoint just in case, because sometimes that comes up. If I was to do a midpoint, I go between the 2 points, and I would take the point in the middle. So anytime I draw that line across, that means that I'm just going to find the length between those 2 points, and I take the y value that's either on the left, on the right, on the middle. I also want to remind you that a trapezoid sum, if you had to do that, is equal to the left plus the right sum divided by 2. The left sum plus right sum divided by 2. So this is just extraneous information. Rewatch that if you didn't get what I said there. Okay, so let's go and do our right Riemann sum. Our integral from 4 to 12 of p of t dt is going to be equal to, approximately equal to, let's see here. Let's get some colors. I need to go from 4 to 8. So 4 to 8 is 8 minus 4. So 8 minus 4 times p of 5. P of 8. Because I went to the right. Plus, and now I'm going to go 11 minus 8 times, because that's the width of the rectangle. The height of the rectangle is on the right, so p of 11. Plus, now we'll do one more. 12 minus 11, because that's that last width, and then drop to the right of that interval, drop to the right of that interval, times p of 12, and then you'll get some great answer here. So it's going to be 4, so if I just plug in the numbers here to show that I know what I'm talking about here, it's going to be 4 times, so again, this will be equal to now 4 times p of 8 is 5, plus, and then we have 3 times 8, and plus 1 times 4. And again, on an AP test, if you if you don't have time, move on. Don't worry about calculating that. If you did want to calculate that, you get 48 total. Now, I would recommend, though, that you make sure you always include units when a problem gives you units. Always. Even if you don't think it asks for it. Always include units, because that could be where they give you a point, because you're understanding, like, how to interpret it. So what are the points here? What are the units here? Well, it tells us that P of t is a rate at which online orders are processed. And when we take the integral of a rate, we get the original function. In other words, the integral of the rate, and the rate was orders per time, means we just get orders. So what we calculated then, is, and this is very specific language, so I'm going to underline this, from t equals 4 to t equals 12, there were 48 online orders processed. Okay, and that's my answer. I want to point out that my answer is going to be extremely similar, absolutely extremely similar to this statement. Like, I will regurgitate that back to them. I will spit that right back, I will send that right back where it came from. When they give me that written out, I'm using that in my sentence. I am not straying from that because I'm answering their sentence and I'm answering their question in a complete sentence. And there's your answer. That is the meaning of your answer in the context of the problem. Let's go on to the next one. Given that s of 0 equals 1, find the equation of the line tangent to s at t equals 0. Okay, freeze here for a second. It says s of 0 equals 1. When that means that when t equals 0, s equals 1. So be aware of that, because t is your x, s is your y value. And you're going to need that in this problem. Now it says find the equation of the line tangent to s at t equals 0. So the reason I said that was important is because if you try to plug in t equals 0 here, you would be totally wrong. When t equals 0, s equals 1. So the first thing that you need is that when your derivative, when ds dt at t equals 0 is going to be equal to a 1 over 8, because s is 1. So your slope is 1/8. Now let's find the equation of the tangent line. So the equation of the tangent line is going to be y minus the y value, which is 1, equals 1/8. That's your slope. And then t minus 0. So that was kind of silly. We could have just written this as y minus 1, or rather y equals 1/8 t plus 1. Any way you write this is fine. That is your equation of the tangent line. That takes care of the first part of the problem. Now it says use your equation to estimate s of 4. So we don't know what the s of 4, let's do this in a different color. S of 4 says when t equals 4, what's s equal to? Approximately equal to, because we're going to be approximating. Okay, so we have to find that, and we're going to use the equation of a tangent line. Now let me back up here and show you something about a tangent line. A tangent line, if you draw a tangent line on those 4 fundamental curves, a tangent line can either under-approximate or over-approximate. A tangent line can be under a curve or over a curve. And that happens when a curve is either concave up or concave down. So what I need to approximate this, to determine if my approximation is going to be an over or under approximation, is going to be the second derivative. Now let me back up here. I didn't answer this part. It did say to use your equation to estimate s of 4, so let's just do that. Let's do y of 4 is equal to 1/8 times 4 plus 1. That's going to be a half plus 1. Again, you could leave that as your answer. 1.5, either one of those would be fine. So that's your answer for the second part. Please note that, and I'm sorry, I should put units here. We are talking about orders, 1/2 orders, 1.5 orders. It doesn't ask me to explain what this means, other than explain your approximation, but S of 4 is approximately going to be 1.5 orders. I did want to point out that if you put an X here anywhere in the problem, you will get that wrong. I had mentioned that to a few groups during the mock one that you guys did on Thursday, Friday. Please make sure you're putting T's and not X's. Okay, last thing, you need to take a derivative here. So the derivative is going to be a little bit tricky. d2s dt squared, and we need the second derivative for those reasons. We want to see if the function is concave up or concave down, is going to be equal to, if you take the derivative of s over 8, it's just going to be 1 over 8, because remember s over 8 is the same thing as 1/8 s, and the derivative of this is the slope, which is just 1/8. So we have 1/8 times, now the reason we need a times here is because I just took the derivative of s with respect to time. So I need a ds dt here because that's the chain rule, it's implicit differentiation. I took the derivative of something that wasn't t with respect to t. So I have to put that ds dt there. And then what I always do after that is that I have to do d2s dt squared, the second derivative, is going to be equal to 1/8 times whatever ds dt was, which was s over 8. One thing I really neglected to say is I'm using this equation, the top equation, because I'm at t equals 4, and t equals 4 falls in between 0 and 8. Okay, what I get here is I get s over 64, and s always has to be a positive number, and in our case I believe it was, actually I have no idea what our value was. but it doesn't matter. S is always a positive number, which means that this value is always going to be positive. The reason I know S is always going to be positive is because there's always orders to be shipped. And because I have a positive second derivative, then my function is concave up. And concave up means that I have an under approximation. So because d2s dt squared is positive, because the second derivative is positive, the function is concave up, then s of t is concave up, is CCU. That part is optional, you didn't have to say that, which means that you have the tangent line is under approximating. I'll just write that last part, tangent line is under approximating. That's not green. Tan line is under approximating. Okay, so those are our three answers. It looks like we got all those correct, so I'm going to go to the last one. Okay, Webwood Books incurs a cost of 90 cents for every order shipped. Notice for every order shipped means that I'm going to use S of t. I'm not going to use P of t here. Find the total cost for all orders shipped during this 12-hour period. Okay, so 12-hour period means I need both of these equations. What I want to do is I want to find how many orders were shipped all together, and then I'll just multiply that value by 90 cents. And in order to get how many orders were actually shipped, I need to integrate the rate. So this whole problem is just asking me to do ds dt from 0 to 12. Note though, from 0 to 12 I have two different functions, so I'm going to need two different integrals. The first integral is going to be the trickier one of the two, so I'll take some time to explain that. We're going to do the integral from 0 to 8 of s of 8, s over 8, dt. That's going to be a tricky one, so I'm going to put a little star by that. Plus the integral from 8 to 12 of 4e to the t over 4 minus 1 dt. I'm sorry, that minus 1 is up there. Minus 1 is up in the exponent. dt. Let's start with the first one, the second one here. I'm going to do u. If u equals t over 4 minus 1, du is equal to 1/4 dt. dt. I don't have a 1/4, so I have to compensate. I have to put a 1/4 inside. I'm going to multiply on the outside by 4. Now, when I multiply by 4, this 4, and I take this 4 on the outside, I get 16 for this integral. So I'm going to now get 16 times the integral of, and I'm going to change these limits of integration, e to the u du, and the limits of integration I'm going to plug in here. I'm going to plug in an 8. I'm using all my colors. I'm going to plug an 8 in for this equation, and 8 over 4 minus 1 is 3, because now u is 3. And when t was equal to 12, u is equal to, let's just use all my colors here, t is equal to 12, u is equal to, so 12 over 4 is 3 minus 1, so u is equal to 2. That seems wrong. I see what I did here. 8, 12, 4, that's okay, so this is 2. When I plugged in 8, I believe this u is equal to 1. So let's just change that. And that makes sense. So u is equal to 1. So now I can evaluate this integral. Doing top minus bottom, the antiderivative of e to the u is e to the u. I'm going to get 16. Then I'm going to get e to the second minus e to the first. And that's going to be the first part of the answer. I'm going to add to it the other half in just a minute. So the other half. My problem with this, the biggest problem that students will walk into a trap with, is I have an s here and a t there. And you're not supposed to integrate variables that don't belong in the integral. So let's just look at this part. ds dt equals s over h, because there's a shortcut to this. And it came up in one of our review videos just recently. We'll do all this work in brown. ds dt equals s over h is the same thing as writing, and I'm going to get a smaller font here, as ds dt equals 1/8 s. A couple weeks ago, I had taught you that if you have something like dp dt is equal to k times p, that means that you have proportionality, that your rate of the population is growing proportional to the population. Again, proportionality, when there's a number in front of the y value. And if you can recognize that, a number in front of the y value, if you can recognize this, then you can jump right to p of t as e to the kt. Automatically. You don't have to integrate anything. I'm thinking here, because take a look at it. If you take the derivative of p prime of t, which is dp dt, then you get k e to the kt. The reason you get k e to the kt is because the derivative of an exponential is itself times the derivative of the argument, and the derivative with respect to time is just k. And e to the kt was p. So k times p. So again, this was a long-winded explanation, and you already have a video for it, so I'm going to leave it here, that you do not have to find the antiderivative here using complicated ways. You can just jump right to it and say that ds dt is equal to, s of t. So here, ds dt was equal to 1/8 s, which means that s of t is equal to e to the 1/8 t. Done. Okay, so now we need to integrate that though. So let's integrate that, and we end up getting out. So let's bring this up here now. The integral from 0 to 8. I'm sorry, that's not what I want. The antiderivative is e to the 1/8, and we need to evaluate top minus bottom. So we will get e to the 1/8 times 8 minus e to the 1/8 times 0 of top 8 minus bottom 0. And let's see what we get out here. We get e to the first minus 1/8 times 0 is 0, so minus 1. So we have e to the first minus 1 plus 16e squared minus e to the first. I'm going to clean that up slightly here. I'm just going to say that this is, just combining like terms, is going to be 16e squared minus, I have minus 16e's at plus 1e, so minus 15e. Then I have this minus 1 here, over here. Then minus 1. So this is the total number of orders that were shipped. Each order is going to cost me 90 cents. So I have to take that 90 cents and multiply it by the total I have. So 0.90 times 16e squared minus 15e minus 1 is going to be my answer. And again, if you're short on time, this would have definitely sufficed for your answer. Or you could have simplified it if you had the time and gotten $68.81 as the cost of shipping for Web of Books. I believe that's all. Thanks for watching, guys.